Hello everybody, welcome to the new video. Today's episode will be about this device, why I made, how I made. So let's get started without any interruption. These two rechargeable batteries from Tiger, and the biggest problem is to figure it out, are they shitty or not. I suspect they're shitty, but we're engineers, we need to prove everything. So, idea is following. I have orange Pi here, I have on a screen here, and actually two of these modules with ENA chip. So the idea is following. I have this orange Pi, so it will be actually using I2C to send data to the orange Pi. Orange Pi will be actually recording this for us to the whatever it wants, and then actually give it to me. Could be using Grafana, but I don't want to make it too software and still keep it as a good hardware solution. So probably auto-mounting USB stick and writing into it. I have my Orange Pi connected by internet and some Python library file. And I actually can get my voltage and current from the batteries. I need to get something to load it. So as you can see, I soldered a bunch of wires there. And in my devices, as you can see, I soldered a bunch of wires, so you can see all of them connected, and it does a lot of nice features, so I need to finish my software. So the display initially doesn't work. The problem was that it really requires 5 volts for powering, and right now, if I run script, it displays something so nice. We can continue. I'll have some updates, some kind of UI is working here, and now I'll be trying to connect battery power and to short the line. So right now I have some updates, basically on the screen displaying something, and now I'll be connect my battery pack and try to connect something to it. But I actually thought that using the simple resistor for discharging is not really a great idea because the current will be changing as the battery is discharging. So I guess we can use something more smart. For example, linear stabilizer. We didn't have very much current here, just over 100 milliamps. So we don't need any heatsink, anything. So we can use one of these. Running. I have some random batteries inside the holder and my element module. Oh, resistor is a little bit hot, but I guess it's fine, will be not burnt. But half of 1 watt it's consuming right now. So yeah, I forgot to 3D print updated version with the hole, so did it manually so I can screw up my Type-C connector. So right now I'm installing my screen, so I use very small standoffs, M2 screws. Hope it will be really okay to do that. So yeah, I have screen installed, I have Type-C port installed, so now I need to wait until the second revision of the case will be 3D printed, then I can finish all the parts installing. To the finish, I actually inserted inserts required for the finishing this project. So the next thing, I will desolder all the wires I have now. Yeah, almost installed all the parts, only this tiny piece left. I will just double tape it, and then I need to do my wiring. So yeah, right now I have it installed. So the next thing is soldering and more soldering. So yeah, I finished all my wiring. It's really messy, but should work, so it's fine. Remember, this is prototype, so in the beginning I tried to make it as nice as possible, but then a lot of new wires was being required, so it's like that. It's fine, don't worry. So this is actually almost ready version of the project. As you can see, it's running, it's discharging the 2 batteries I have. On the top, there's USB stick, an internet connection cable, and on the screen it displays a voltage, current. So we can see we are 2.77 volts now. And I started using element 317 circuit that I want to discharge it with 100 milliamps current, and it automatically actually counts how many points left before it finishes tests. So as we can see, device, it's asking for a USB stick. So I'm inserting one. And after some time, it detects it and starts automatically running the test for the batteries are inserted. So now I will tell you how I did it with this device. To ensure that I have full overview of this device, I also want to show the code. So the code is in Python, don't hate me. I think it's acceptable right now for the first prototypes. In the future, if there will be real demand, I will be rewriting everything on C, make the proper PCB, and make this project really proper. However, the code is pretty simple. So we have all the logging stuff here. Then it basically initializes display with all required features. Here it just updates the main screen, which is basically this screen. So this code basically just updates it. So also we have attempt to do our USB insert animation. It's shitty, I know, I need to redo it. And in the main code, we just set up our chips for current measurement and voltage measurement. Then we set correct shunt resistor because it's 100 milliamps instead of default values. Then we basically display waiting for USB stick and its animation. And here we have another class which is responsible for USB. And this function is blocking. So basically it will be wait until USB stick is plugged in, and only then it will be allowed to read config from the USB stick. It should be in test.json file on USB stick in a root directory, which basically detects what the test is required. And then basically it creates Python data frame, which is very easy to use later in Python for import export. This data frame, then in a first recording, it just records voltage one time, and then basically, and based on that, it calculates on which amount of voltage drop it should record the point. So the idea is following. You can set amount of points and cutoff voltage, and the software will be evenly record the data on even distance between these points. So the next thing is basically the main loop, which basically records the data from the INA chips, displays on the screen. So this if basically checks the cutoff voltage. If it's reached, then stop recording, display the text, and basically save data. Currently I'm saving to SCV file. It's not okay, I will be fixed it later. By the way, check on the link in the GitHub. I hope I really fix these things by the time you're watching this video. So, and here we can see another thing, it's basically checking amount of points and also recording file just in case if it's not recorded before. So here we go to the very handy file init USB, which basically is responsible for USB. So it's use pi, notify, and couple of Linux magic commands like lblk, things like that, just for detecting USB sticks and mounting it automatically. Moreover, it also reads test.json and actually sets parameters for the test. And of course, the records export file to the USB stick. So the code is something like that, not really handy, not really complicated, but it works. Thank you very much for watching my video. Please subscribe, like, and stay tuned. A lot of more cool electronics are coming soon.